Hello everyone, my name is Mr. X. I am a second year education student pursuing a degree in middle years. I would like to begin this presentation by acknowledging my presence on the traditional territories of the Treaty 4 and Treaty 6 peoples on which the University of Regina campus is located and operates. I am thankful for the opportunities to live and learn on the ancestral lands of the Cree, Ojibwe, Saulteaux, Dakota, Nakota, Lakota peoples, and on the homeland of the Métis Nation. I respect and honor the treaties that were made on all territories and acknowledge the harms and mistakes of the past. Indigenization and sustainability are our shared responsibilities, and I am committed to moving forward in partnership with the Indigenous nations in the spirit of reconciliation and collaboration. For my topic, I chose ocean acidification, which you might not have heard of before. So what is ocean acidification? Ocean acidification is caused by excess carbon dioxide gas in the atmosphere dissolving into the ocean. This leads to a lowering of the ocean's overall pH level, making it more acidic. So how does ocean acidification happen? Well, there are natural and unnatural contributors to ocean acidification. Let's talk about the natural contributors first. The ocean actually has acidity in certain parts, such as underwater hot springs and hydrothermal vents, or in locations where there's underwater volcanic activity. Organisms dying and decomposing on the ocean floor, releasing their carbon into the ocean, also contributes to the ocean's acidity. A process known as natural upwelling also contributes to natural acidity. This is when the wind blows the water on the surface of the ocean and the nutrient-rich water rises into its place. Now let's talk about unnatural contributors. These are contributors that humans add to increase ocean acidification. Burning of fossil fuels such as coal and oil, as well as deforestation, are major unnatural contributors. Deforestation results in fewer trees to absorb the natural CO2 gas in the atmosphere. However, when plants are cut down or burnt and left to rot, the carbon that makes up their organic tissues is released as carbon dioxide into the air, with added carbon and CO2 from humans, the pH level of the ocean drops much more than it should, making the water more acidic. So when did we learn about ocean acidification? Ocean acidification is a fairly new subject in the area of climate change. New discoveries are occurring all the time. In the past, ocean acidification occurred naturally, but over a much longer period of time. It is occurring at a much faster rate today than in the last 20 million years. Scientists have actually been tracking the pH levels of the ocean for more than 30 years, but biological studies on this subject really only started in 2003, when the rapid shift in acidity caught their attention and the term ocean acidification was first coined. So now that we know what ocean acidification is, why should we care? While chemistry is predictable, the details of the biological impacts are not. Since ocean acidification is a relatively new subject, we don't yet fully understand the potential impacts. What we do know is that things are going to look different, and we can't predict in any detail how they will look. I am interested in this topic because we discovered it so late in comparison to other global issues like global warming. Because it was discovered so recently, we can less easily predict what the outcomes are. Let's talk about some of the potential impacts we do know about and why they create an increasing urgency to act. The coral reef is greatly impacted by ocean acidification. Here is a before and after of a coral reef impacted by ocean acidification. As we all know, the coral reef is home to a large variety of plants and animals and contributes to the health of the ocean overall. On the next slide, you will see the direct impacts of ocean acidification on animal life. On this slide, you can see the impact of acidification on the seashell decomposing while its environment becomes more acidic. This demonstrates that acidification will have significant consequences for skeletons and shells due to a buildup of calcium carbonate. But what about the societal impacts of acidification? The fears around increased ocean acidification, like all climate change fears, can cause increased fear and anxiety around the future. As CO2 builds up in the air and cannot be absorbed easily by the ocean, the air quality for humans will decline. Similarly, the ocean's life forms produce half of the oxygen we breathe. What happens to that oxygen when acidification impacts our wildlife? One final societal impact due to wildlife loss is that beyond loss of biodiversity, acidification will affect fisheries, aquaculture, and threaten food security for millions of people, as well as tourism and other sea-related economies. I think that the subject of ocean acidification fits into the grade 5 science curriculum. I have included the outcomes and indicators from the curriculum on this slide. For example, students are meant to learn about the properties of materials in various forms, changes in physical states of these materials, and the impact of manufactured products on society and the environment. In the next slide, I will provide examples of class exercises for this age group that I think will satisfy these outcomes and indicators. To discuss the changes in physical states of material, I might do an in-class water acidity experiment where, as a class, we examine the effects of various levels of acidic water on a plant such as a leaf. We could make notes on how the leaf was affected in the water over time and hypothesize on whether acidity was the cause and how acidity might impact other living beings. To discuss societal impacts of manufactured products, we might discuss real-life impacts of ocean acidification by brainstorming ocean vacation activities that might be impacted by acidification, such as snorkeling, swimming, and water sports. Discussing ocean acidification, like all climate change, can seem pretty hopeless. There is little that individual students can do to impact this major issue, other than to learn about it and advocate in their communities when they can. My meme inserts some humor into the bleakness of the situation to keep things light for students while also educating on ocean acidification and its impacts. I hope you learned a little bit about ocean acidification in this presentation. I'm Mr. X, your least acidic, most basic science teacher. Have a great day.